you know which one is your x and which one is your y. So anything that goes along the horizontal axis is your x, and anything that goes along the vertical axis is your y. All right. Tell me what do you have here? What are the forces around my x-axis? Sorry?
Kinetic force? Or kinetic, yeah.
Friction.
Friction, I'm sorry.
Let's call it friction for now. We're going to spend some time in the difference between. Okay, we have friction. So sum of force along x, you get friction. What else do you have?
We have tension, but it's at an angle.
Okay, so what about it? What are we going to do about it?
We have to find
Oh, this.
using your trait functions.
Well, yeah, so right now, so this comes with an angle, right? So especially for those who want me to work it out, so I want to hear loud and clear. What do you want me to do? I don't want to be writing it by myself.
You can break it into x and y.
There we go. So since I'm working on my x-axis, I'm going to write that. Okay, so it's going to be ftx, right? And what else do I have on my x-axis? Nothing else. That's it, right? And that should be equal to max. Right. All right. Let's do y-axis now. So what do I have along my y-axis? Weight. What else?
Normal.
Okay.
So when would be negative?
With again, we run the vector form, and then once you kind of sort them up, which one will go x, which one goes y, then you start looking at which one is positive and negative. Okay, so right now, I hope you can see the structure. This is basically where you start. You broke down into its component. You get to x and y, you get to x and y. Then that should be equal to this. That component should be equal to that. Right? And then you go and look for the forces along that x-axis. Right? And then we're going to do the same thing along the y-axis. What does that mean? So you got W, Fn. What else do I have?
Mass times acceleration.
Tension on the y.
I've got tension along y.
Oh.
And this one comes with an angle, right? So I have to have an x component and y component. And that should be mass A1. Right, now you have your x and y, you know all the forces that are there. Now you can go ahead now and look at the direction and say which one is positive, which one is negative. Okay, all right. I'm going to write right here. So, friction is positive or negative?
Negative.
Negative. So I'm going to minus friction. The x component of my tension, is it positive or negative? This is the x component. Right, this is the x component. Right. And that should be mass times acceleration. And do the same thing. So what about weight? Is weight positive or negative? Okay. What about normal force?
Positive.
What about the y component of my tension? Positive?
Positive.
That's right. So the y component of my tension is this is a y component, this is an x component. It's positive. Okay. Now, now we can look at it. What's ftx, what's the x component of my tension looks like? How do I find the x component of my tension?
Cosine,
Cosine, so because this is an angle,
20 degrees.
Yeah, I'm going to switch to normal. Yes, switch to normal. So this is that angle. So that's a cosine. I have minus f plus ft cosine theta equal to 8x. And same thing, again, minus W plus Fn. So this one should have
Sine.
sine plus Ft sine theta. And that should be equal to what?
MAY.
That's AY. A minus G, 0, or anything else. What's AY is? Let me give you two options.
0.
0 or minus G.
0.
Why?
Because it's not in free fall.
Exactly. So free fall, there's no motion along again the y-axis, anything along the x-axis. Okay. All right. I think that you should be able to pick up from here. Right. You should be able to solve everything. That you
Yeah. What a mess.
Do you ever think of friction?
Yeah.
Do we ever think of tension like we think of friction having positive and negative?
Friction, usually because friction is associated to motion, and when you break down your motion, you mostly break down the x-axis much with the direction of motion. So, most cases, you can choose a reference rate, or you can have a case where you have to break down the motion so that the reference rate doesn't match it. That's the friction you have x. So the friction always, as in 9% of the case, friction always matches the direction of motion. So you always have only, you don't have any y component.
I was thinking of tension, for example, there, say it's a tow truck filling that.
Yeah.
If worst comes to worst, I'll just put it on a thumb drive.
Tension the way you think of friction, so the tension would be opposite of the direction that it's being pulled in.
What? No, because in terms of physics, you can't think of it that way yet. In terms of reference frame, you don't know how to set up a reference frame. So in terms of physics, excuse me. In terms of physics, that's the physics here. You can't change that. That's totally regardless of the direction that it shows.
The second part you can cover.
Doesn't matter which direction you choose, you're going to have that. In terms of the x and y axis, one of the reasons you can say I don't like that x and y, you say I don't like that at all, I want to do my whole coordinate axis. You're free to do so, it's going to be much harder. You can say, you know what, I'm going to choose that axis and something different. Then you can try to do it. And come and tell me how you did it. I'd like to know. You can, but it's going to be a pain, right? Because there's a natural axis that comes to you, right? Again, you don't have to choose that, but it makes a lot of sense if you do so. Indeed, if you choose one axis that way, then your friction that case doesn't line up that. Then you have to break your friction along the x and y axis, and your tension will be you don't have anything along them.
Is there such a thing as negative tension?
Tension.
Well, there's negative friction, or friction in the negative direction, but there's no such thing as tension.
No, tension is applied force, right? You apply that to something. So you can break down the tension along the x and y axis, but in terms of sign, let's try to move on quickly. Far beyond what I wanted to be. Again, I'll let you solve that and we'll talk about that if there's a problem. Okay. So, one common question that comes in is, or misconception is relationship between mass and weight. We're opening a section where we'll be looking at forces one at a time. So we're going to look at weight, normal force, friction, tension, all those kind of stuff. So we're going to start with the most elementary one, that's weight, right? And this conception comes because daily language, when we talk about weight, we tend to refer to a mass. So there's a difference between those two, right? There's a wide difference. One is a scalar, exactly. Mass is a scalar. This is interesting to you. Your mass doesn't change no matter where you go. You still have that same mass, right? Your weight is a force, and it's based on gravity, a pull of gravity. So if you're on Earth, you'll have a weight. If you are somewhere else where the gravity is different, go to the moon, the gravity is different, and you'll have a different weight, right? So the difference between those two. All right, let's try to get that out.
Oh, is there a timer or it just shuts off by itself?
There's a timer. And usually when it is kind of stays still for a while,
Oh,
the
it
message that
Shuts down.
Shuts down.
That's
Yeah. And also when it's up, kind of does the same. So. So, but nevertheless, I can tell you what I want to say. So mass and weight are two different concepts. So mass has a concept of, mass is a scalar. Here we go. Let's focus first. So mass is a quantity that describes your, basically your brackets, your whatever you have, that's your mass. And weight is a vector, and this on your mass. So now, you can convert whatever you have to talk about mass in terms of where's that? So, weight by definition is mass times gravity. The negative sign is just only telling you it's a vector that points down, and you assume that everything that goes up will be positive, right? The unit of weight is what? This is force. The unit of mass, weight is Newton. And the unit of mass is kilogram. So clearly, there's a relationship between those two. If you want to convert weight to mass, clearly you can divide that by that factor, then we're going to talk about that. Now, and usually this is on the SI, it's a unit. But here we, especially in our daily language, we use English system unit to refer to our weight, to our mass, right? You say our weight, how many pounds, right? And how many pounds basically this is the English system unit. So those are the conversion factor. If you want to convert anything from pound to Newton, this is the first one that is given to you. But usually, what mostly I'm looking at forces, right? If we're talking about force, we have 1 Newton. We want to see how many pound is that. So that's basically 0.23 pound, right? Similarly, based on this relationship here, right? So if you want to find what 1 kilogram weight worth in terms of pound, 1 kilogram is about 2.2 pound. And if you want to convert 1 pound in terms of kilogram, and this is that 1 pound is about 0.45 a kilogram. So meaning, if you go to a bathroom scale and your bathroom scale you have 140 pounds, and I say, well, I don't understand that. Can you tell me exactly what that is in terms of, basically what you're telling me, you're giving me your mass. So I want to know basically in terms of kilogram. Right? So that's a conversion factor you have to do. Right? So 140 pounds, you have to multiply that by basically 1/2 to tell me what it is worth in kilogram. So 140 should be close to 65 to 70 kilogram. Right? So this is basically the language that you and I use when we talk about weight. Right? Let's say this is my weight. You're talking about this, the SI unit is that. Okay? I wanted to work this one, but I think I'll let you do that. Quickly, this is the concept of apparent weight, and how are we aware of weight? Because don't forget that the weight that we're talking about, right? This is not a contact force, right? This is a long distance force. So basically, we feel it, but we don't have the contact. How do we have a sense of weight? And the sense of weight comes from basically the normal force. So when I'm standing like this weight basically communicates itself to a normal force. This is how I know basically what's my weight or what's my mass. But that normal force, if I stand here, that normal force is basically equal to a weight because I'm not moving anywhere. But when you start moving,